Welcome to the final exam. Excuse me, that's my phone. Question number 2. And when we look at this, it gives us the following. It says our 5-inch slab, concrete slab, and we have a change in temperature of plus 40 degrees Fahrenheit, and we have a E of 3 million psi and a coefficient of expansion of that. I won't go ahead and say 0.00, but I just did. Anyways, so here is how I like to think about it. I'm just going to go quick explanation of what the thought process is if something were restraining this slab from expanding, it would be the same thing as letting the slab expand and then forcing it back. What would that additional force be? And this is a hard question. I would say I wouldn't expect a lot of people to get this, and simply because you kind of have to mess with 2 equations, and I'll show you real quick. So when we think about it, what equations do we want to use? What equations do we know? You have a temperature, and the first equation, which is like change in L, I guess, change in length, we can call it delta L, equals your coefficient of expansion times your change in temperature. Sometimes I'll put that in a box because some people like to say, hey, that looks like two different variables, but it is not. It is only one. And then we also have L, and that's your original length. We can call it L naught, if that makes any sense. You just call it L, whatever you want to call it, I guess. Anyways, and then we also, what else do we know? And if you'll go back to, I think it was chapter 1 or 2 or whatnot, you'll see that delta L, or tell you what, let's get rid of this L, delta L. Let's just call it L, or delta. And that's our change in length here, equals PL over AE. And remember, that's for axial type loads. And this is an axial type load. It's just a really thick, really wide and long axial type loads. It would be the same if you just looked at it with maybe you could say, well, I'll tell you what, that's kind of hard to see. Let's make this a lot smaller and say, okay, I changed color somehow. Say, well, let's just do a box right here, and what's known, it's a known box. So you could say, oh, okay, now that makes it look a little bit more realistic. And if you went any smaller, you would go in, and it would be this box that looks more like a column. If you got real small, so you still have that 5-inch. You have a 5-inch tall column, but it's only 1 inch by 1 inch by 1 inch by 1 inch. So now you're saying, oh, well, that looks kind of like a steel bar, like we did earlier. But anyways, you still have this same equation. If you look at it, we can combine these because we both have the deflection, axial deflection. So let's make them equal to each other, and then let's see what we can get rid of. So if we say PL over AE equals times the change in temperature times L. Remember, this is L naught is the same as L, and let's go ahead and just call it L. I don't want to confuse anybody, so we can call it L in both situations, but remember it's the original length. Alright, so let's go cancel stuff out. We have L on this side, we have L on that side. Let's get rid of them. And then you get stuck and you're like, oh shoot, well, we have the coefficient of expansion, we have delta T, and we have E, but we don't have P over A. Well, that is actually what we're solving for. And this is why I thought it was a difficult question to ask, because P over A actually equals, it is asking us to find, if the restraint against movement, what is the internal stress developed in the concrete? It's asking us, what is the stress? And the axial stress is actually P over A. Axial stress. Alright, so we can substitute this, P over A, for axial stress, or just F, or however you want to denote it. And we can move E over here, so we actually have FA equals, we have to multiply by E, and then E. And let's see what we get. So we're going to solve. So 0.012345 zeros, 65 degrees Fahrenheit per inch. Let's say. I believe that is what it is, and I'm horribly too lazy to go look it up, so I apologize. And we have a 40 degrees Fahrenheit change. And then we also have E, which is 3, 2, 3, 4, 5, 6 zeros PSI. Alright, so I'm going to move down here and we're going to solve. Get my handy calculator out. So we have point many zeros times 40 times 3, 1, 2, 3, 4, 5, 6 zeros. We get 780. Now let's try and figure out, it should be in PSI, correct? Excuse me. These inches, I guess, are canceling out. Inch per inch, this would move up top, those would cancel out each other, this cancels out with that, so we should get just PSI. And that is what we got. Let's see if that's an answer. 780 PSI. So right off the bat, I'm sorry I didn't do this. It's a little test taking thing is look at your stinking answers. Go in there and say, okay, I know right off the bat I'm going to be expanding and it's going to be pushing back. That's compression, because this is going to be pushing down. Just think about it. Okay, I let it go and then I push it back. I push it back. You have to push it back, and when you push it back, that's causing compression. So you know you can get rid of B and D, or sorry, no, you can just get rid of B. Sorry. So you can just get rid of B, and that at least leaves you with a 75% chance, or a 33% chance of getting it right, and if you have to guess. But the answer is A for number 2. Number 2 equals A. All right, I will see you on question number 3.